Alright, hey everyone, we're going to get started with the next problem. It is problem number 890, find and replace pattern. It has an acceptance rate of 69.7% and it's rated as a medium. Let's just get started. So it says we have a list of words in the pattern and we want to know which words in words matches the pattern. A word matches the pattern if there exists a permutation of letters P, so that after replacing every letter X in the pattern with P of X, we get the desired word. Recall that a permutation of letters is a bijection from letters to letters. Every letter maps to another letter, and no two letters map to the same letter. Okay. And then return a list of the words in words that match the given pattern. You may return the answer in any order. So that was pretty confusing in my opinion. I want to look at the input and output. So they give us this input array words, and it's just an array of strings. So you have A, B, C, D, E, Q, all these, and then we have a pattern A, B, B. So our output should be M, E, E, and A, Q, Q. So I see here that A is one letter, and then B, B is another letter. Here, M is one letter, and then EE is another letter. So, these two were the same, and these two were the same. Also, when we go from, and in this case, these two are the same, and the Q maps to the B, but A maps to A still. So we can have different mappings for different strings. So here, M maps to A, here A maps to A. And then, these were the only ones because if D maps to A, E maps to B, then Q cannot also map to B because of this stipulation here that says no two letters map to the same letter. Okay. At first I was thinking that if we just took like M minus A, we'd get the number to subtract each string by, or each character by, but it seems like that's not the case because M minus A isn't equal to E minus B. Let's see how we can do this. Let's come up with a brute force. So I think I have a clear understanding of the problem, and they even explain here, me matches this pattern because there's a permutation where A maps to B, B maps to E. CCC does not match the pattern because A maps to C, B maps to C. It's not a permutation since A and B map to the same letter. Okay. So you can't have a letter map from here to here be the same as another letter map from here to here, and then as well you can't have a letter map from here to here be mapped to here. Okay, now I'm confusing myself. Let me get this, and we can maybe draw some stuff out to see how we do this. Let's just pick an array of, say, three words. Max, tree, and ABB maybe. So one thing I see here is the letters have to be the strings have to be the same length. So that's one check we can have. Strings must be the same length. So this tree will actually just get thrown out if our pattern is 3 letters. And I'm assuming this is like sort of like regular expression matching, but to do CCC. And so that's our array of words, and our pattern will be, let's say 3 distinct characters. So A, Y, Z. how do we do this? So we start through every, this is all part of the understanding again. So we start through every string in this words array. We take max and we see if it matches the pattern A, Y, Z. So we say that this M maps to A maps to Y, and X maps to Z. If there are any, so how do we do that? We said that M maps to A, so M to A, but we also create this mapping of A to M because they can't be duplicated. So here, A maps to Y, and Y maps to A. It's a bidirectional mapping. Okay, and then X maps to Z, Z maps to X. So in this case, because there was no collisions on these bidirectional mappings, we can include this as part of our return output. So we have to actually return the output, and it's just a list of string. Okay, so we'll add it to our list of string, and this will be, let's just say, max. Let's not close it right now. Then we take tree. So let me erase this. Then we take tree. So tree with, what was our pattern? Shoot. Our pattern was, I believe it was AYZ. Yeah. All right, AYZ. So we check tree's length with AYZ, they don't match, so there's no way it can be permutation. So we don't include that. And then we move on to CCC. And we check it with AYZ. So we start off with the first character. C maps to A. And then we see this C already maps to an A, so it can't map to Y. And therefore we don't include it. Sorry, let me just get some water. Alright, so we saw that C already have a mapping, so we can't map this C to another letter. That's not A. And so because of that, we just exit. So here I see what we're doing here basically is a hash map from character to character. And I'm wondering if there's actually a better way we can do this. Regardless, there is only 26 characters in the alphabet. We're going to assume that we're using English lowercase alpha characters. So there's only 26. So you could argue that it's not really O of n space. You can say it's O, big O of 1 space, because at most, or you'll always have only 26. You have a constant number of space no matter the size of the input in this part. So I'm going to go along with that assumption. We don't have to use a hash map. We can just use an array of size 26. And that's constant no matter how big this string here is or this string here is. So we're going to have some sort of map. We need two of them actually, because we have one here and we have one here. So basically how we're going to have to do this is iterate through, starting the plan. As you iterate through words array, so we're going to have like that outer for loop. We're going to have a check to see if it's a permutation. If it is, then add to the list. Add to list. Else we'll just continue iterating through the rest of the list. And so the part where we want to get more in depth with the pseudocode is how do we check if it's a permutation? So the process we just described is we have two maps or two arrays of 26 indices each, mapping one character to another character. And I'm assuming these are all lowercase. Let's see. Actually, we can't really make that assumption, it seems like, because it's not specified anywhere. If we clicked run, let's just return null. I want to see, do they give us, no, so they only give us lowercase. It's the same example from above. So, alright, let's assume that they are lowercase for right now, because this input shows as such, and if it's not, we will adjust. We have our two arrays. Mapping letters of the alphabet from string x to y and also y to x. Once we have that, we're going to keep creating this, adding to this map, add to the map as we iterate through the strings. If we get to a character in a string where there's already a mapping, but our mapping shows something different. So yeah, when we have an integer array, it'll be of size or index. Okay, when we have an integer array, the default element in each index is 0. So if we have a collision, or an inconsistency, we can say that it's not going to be a permutation for sure. So we can just return false. And if we get through the whole string, when we've reached the point where we've iterated through the whole string, we can return true because we know that there was no inconsistencies in the mapping. So if we reached here, we just want to return true. Let's see, there might be a better way of doing this, but we can actually check where we're doing any repeated work or anything like that as when we've implemented this, and we can see in our code, like, here's where our bottlenecks are, and here's what we've done repeatedly. So let's go ahead and implement this. So we're going to have our list of type string. Let's just make it an array list. Match the patterns. Strings that match the patterns, but we'll leave match the pattern. Let's have it be an array list. We just want to append. And then towards the end, we'll just return match the patterns. And now this is where the meat of our work goes. So we're going to iterate through every string. So let's say for string s, that is a part of words, we want to do something with that. We will say if it's a permutation, and we'll pass in the word that we're at, and we'll also pass in the pattern, because that's something we need to check against. If it's a permutation, we will add this string s to match the patterns. I believe it's add or append. I'm going to assume it's add. We'll add in s. And we said else, we continue, so we don't need to write that else case. Let's go ahead and implement this function is permutation. And let me also zoom in. So we have this. Let's go ahead and implement. It will be a public Boolean. It's going to be called isPermutation, and it'll take in two strings to match, and string, let's just say pattern. And so here we have what we described as, we need the two arrays, so let's just say a int array of size 26. Let's say to match mappings, and the other one will be pattern mappings. So let's just say 26, and we'll have this one as well. After that, we want to iterate through this string to match. So we're going to actually iterate through both of them. So we need to use the for loop where we can have an I. I is less than to match dot length. Or is it size? I'm going to assume it's length. I++. Forgetting some stuff already. So we also said that we can just do a quick check for if the lengths are the same. If the lengths aren't the same, if to match dot length doesn't equal pattern dot length, the length of the pattern string, we can just return false and save ourselves from doing this work. After that, what we want to do is we're going to actually have a 1 to 26 mapping. So if so let's have this character s, or not s, sorry. Let's say a character, sorry, char to match char is going to equal to match dot char at I. And this is again pretty like not cleaned up or smoothed out or sanded out. It's pretty rough, but we can go ahead and go back and clean it later. I just want to get like all my thoughts out that we had in the pseudocode and try to put it in code. Pattern character is going to equal this, and so we'll check the to match mappings if it's already there. So if this to match mappings okay, yeah, we need this minus a this minus A. And the reason for that is because we have this array of 26 indices, so we want it to be 0 indexed. If two match mappings, okay, so this. If two match mappings at this index, two match char, if it doesn't equal 0, that means we have already put a mapping. So we just want to check that if this pattern char is, if it's going to be equal to, that means it's correct. If it doesn't equal to whatever is in this two match mappings at this index, and because A minus A would be 0, and we're doing this does not equal 0 check, I'm going to say +1. So if this doesn't equal this -1, then return false. Otherwise, we just want to add to, so it equals 0, and then we just want to add to this map. So two match mappings, and I noticed here we created these two arrays, so we have two match mappings and we also have pattern mappings. We have to definitely check that they're not matching both ways, but first I'm going to try to implement the one way first. So if that, else we want to take this, seems like we'd want to do this, and at this two match char is going to equal pattern char +1, right? So when we have that, we have this. We also want to add it to, let's go ahead and put the pattern mapping one. Pattern mappings at this pattern char is going to equal two match char +1. And here we just want to do this check. If the pattern char does not equal two match mappings and two match char does not equal pattern mappings at this index, pattern char -1. So if it doesn't equal that, we want to return false. Otherwise, we will just return true. So, okay, we have that. Seems like we had everything we wanted. So let's go ahead and run through this. So we're given let's run through this mini example with our code. So we're given this. Given a list of words. Let's take this example we had. So let me just copy this. Max tree and CCC. Max tree CCC. So imagine if this was our input array of words and our pattern was A, Y, Z as before. We're going to iterate through the words and then check if it's a permutation. So it'll come here with max and A, Y, Z. Sorry for the messy handwriting, but sees that they're the same length. So match.length is equal to pattern.length, so we don't need to return false. We'll create this array of these two arrays. I'm not going to draw all 26 indices out, but right now they're all 0, 0, 0, 0. I will draw out these 3 indices for, let's just pretend this is A, M, X, and this is A, Y, Z. And we have all the other indices in there, or every other element for each character in the alphabet. But let's pretend that's already there. We just care about these 3. So we're going to iterate through the 2 match string. So we have I equal to 0, and we will actually be checking both. So we take this 2 match char is going to equal this char minus A. So M minus A basically gives you, let's see. Let's take a look at the ASCII characters. M, lowercase m, is 109 minus 97. So let's do 109 minus 97. I should know that m is like the 13th letter in the alphabet, and I think, or 12th, let's see. 2 and 1. So it's the 12th letter. So actually it's the 13th because it's a 0 index. So we have this 12. 2 match char is going to equal 12, and pattern char is going to equal 0 because A minus A is 0. So we say if 2 match char, or 2 match mappings, so this is our 2 match mappings, and this will be our pattern mapping. I'm just going to put T0 and M for 2 match mapping, and then PM for pattern mappings. So we'll say that if 2 match mappings and this index 12, which is M, does not equal 0, which in this case it does, so we'll go to the else case and we'll add in 2 match mappings at that index, pattern char plus 1. So we'll add in, this becomes a 1, and same thing goes for the pattern mappings. So pattern mappings at pattern char will become 13. And we'll continue on, I becomes 1. So now we're comparing A and Y. So A is now index 0, Y minus A is, so Y is 121, minus 97, 121 minus 97 is going to equal, let me just make sure that was 121, yeah. So 121 minus 97 is going to be, we get a 4 here with this 1 and then 1. So this becomes 24, and makes sense, X, Y, Z. Yeah, okay, 24, and we'll say that we have to check here 2 match mappings at this 0th index. If it doesn't equal 0, which it does, so we go to this else, we add in 24, or actually 25, sorry, and this pattern mappings at index 24, so at the Y becomes 1. That's it for that one. I becomes 2. So one thing I'm seeing here is there might be a bug in the case where 2 match mappings at this index doesn't equal 0, but, or I mean, will not equal 0, or will equal 0, but the pattern mappings at this index will not. So in that case, that means that something is already mapped to it. So we can go ahead and add this check. It has to be an or so this cannot equal 0, and this cannot equal, or this cannot be equal 0. Oops, my keyboard got stuck. Oh no. Let's see what I can do. All right, let's just disconnect this keyboard. All right, connection lost, connection regained. So we have this lost keyboard connection again. Okay, that's cool. Oh, never mind, it's back. So this should not equal 0 either. Or if it should equal 0 as well. Only time you want to go into this is if that doesn't equal 0 or the other one doesn't equal 0, which is correct. So we cleared up that bug. We can see that it works for the max to AYZ. Let's try it with the CCC one because that's the only case that I feel like could test this out properly. So we have CCC and AYZ. Because we know for tree it's actually just going to return false because of the initial check we have. So let's just say we have our two arrays of, this one just has to be C. So index C, I'm not going to draw all 25 other ones. This one just A, Y, Z. These are all 0. So we take C, map it to A, so C becomes 1, C is the third, so this is 3. Now we're at I equals 2. We come in here, we see that if this 2 match mappings at this index doesn't equal 0, which in this case it doesn't, so we enter this if condition, and we see that if pattern char does not equal to 2 match mappings, pattern char does not equal to, so it doesn't. This is a 1, in this case is Y. So what's stored in this here is A, basically, and what we actually have is Y. And this shouldn't be an and, it should actually be or. So this 2 match char, or this 2 match char, yeah, doesn't equal this. Okay, cool. Or this doesn't equal this. All right, let's try it out. Let's run this code. I feel like I have a bug somewhere in here in my for loop. And there might be a better way to do this. From int to char. Possible lossy conversion from int to char. Okay, let's just say this is int. Int. Oh, what's this? That's weird. Now let's run it. So we got the same answer that they got. I'm hoping that there is no bug like I assume, and it doesn't error out, which I feel like it will. So it's judging, and it was accepted. So there was no bug that it caught actually. So I'm not really sure what I was thinking. Let's go ahead and evaluate the big O runtime and space complexity of these. So here we see that we have to go through every string. So it's already big O of n, where n is the number of strings. And for each string, we're checking if it's a permutation. So if we let n represent the number of strings in words, and we let m represent, let's say, the number of characters in the longest word, it'd be n times m, big O of n times m, because for every string s, we're checking if it's a permutation. And to check if it's a permutation, we have to iterate through every single character of the string at worst, right? So that means it's big O of n times m in terms of time complexity. We could also say let n represent the number of characters in this total string array, and in that case, it's all a matter of, I guess, the way you frame it. It would be big O of n time, where n is just the number of characters in all the words combined. But let's just leave it at big O of n times m. And in terms of space, we have a constant space complexity, except for this matched pattern. So we could have all of these words be a permutation of this pattern, and we have to have a list that we return. So it'd be big O of n space, where n is the number of words. This is permutation. It's constant space again because this is 26 every time instead of like 2 match dot length or whatever. So that's big O of n time, or space, sorry. Big O of n space because of this list we have to return. I want to look at some of these other solutions because, so approach 1, 2 maps. This is the one we did. If, say, the first letter of a pattern is A and the first letter of the word is X, A maps to X, but we have to write that X also maps to A. So that's correct. We did that. So this was our solution, n times k, and space complexity is n times k as well. Okay. I would make the argument, like I said, where this k is going to be constant because there's only so many letters in the alphabet, or in lowercase, so it's 26, but to generalize it, it would be n times k. I see that. Okay, so they got their space down to 1 map. As in approach 1, we can have some forward map m from L to L, where L is a set of letters, however, keeping track of the reverse. We could simply make sure that every value m1 X is the codomain reached at most once. This would guarantee the permutation exists. So our algorithm is this. After defining this m1x, make sure, okay, so how did they do that? Oh, okay, so they kept 1 map, and they did the same thing we did, but instead of having added to the second map, they'll just go through this pattern again, or sorry, not pattern, the word again, and check if it's already been seen. So we have a Boolean array with this, and oh, okay, they're just checking that these values are distinct. Got it. So we have a map from A to, let's say, X, and then another map from, or we mapped character A to X, and then we also mapped character B to X. We want to check that the values aren't the same, so they're distinct. So we have this Boolean array where we store if it's been seen before or not, and if it has been seen, we'll return false, otherwise we'll return true, or we'll set it to true. So it's still the same big O space and time complexity, and it seems like this is their official solution, so that's the most optimal. We were pretty close. It was just a matter of tweaking. We had to see that our bottleneck was the 2 maps, and that could be improved just by doing this. So I really like this, like, I guess, algorithm for this intuition that they had to just check for duplicate values. That's something I definitely want to keep in mind as I move forward. It's always good to get like tips and tricks as you work through these problems instead of memorizing the solutions. So cool, that's it for this video.